Let's do some more proving trig identities. This video will be another 10 problems if it's not too long. Okay, so this is from the Stewart Precalculus textbook, chapter 7, I believe. I don't know what edition. I can post it in the description later if needed. Okay, here's number 11. Sine of 2x over 1 plus cosine 2x equals tangent x. So let's start from the left-hand side because I would have no idea how to start from tangent x to go to sine 2x over 1 plus cosine 2x. Okay, so let's rewrite the left-hand side. Sine 2x over 1 plus cosine 2x. We know that there are identities for sine 2x and cosine 2x. For sine 2x, the one to remember is 2 sine x cosine x. Okay, and then cosine 2x, there's multiple versions. The easiest one to remember is cosine squared x minus sine squared x. And you can easily derive the other ones by the Pythagorean identity. Okay, so now from here, what can we do? Well, we want to get tangent x, that's the goal. So maybe we want to, I'm thinking, because I'm writing on the side, tangent x, we know this is sine x over cosine x, right? So we maybe want to get what we have right now over here, what I just underlined. We want to get it into sine x over cosine x. So we probably want to get a cosine x on the bottom to cancel the cosine x on the top, or cosine squared maybe. Okay, so well, 1 minus sine squared is what? It is cosine squared. So we have cosine squared x plus cosine squared x, which we can combine those two to 2 cosine squared x, and these 2's cancel. 1 power of cosine on top cancels 1 power of cosine on the bottom. So this is sine x over cosine x, which is equal to tangent x. There we go, right there. Next, number 12. We have cosine of x plus y over cosine x sine y equals cotangent y minus tangent x. So I'm thinking let's start from the more complicated side, the left-hand side. Once again, get it to the right-hand side. Well, we know some identities for cosine of x plus y as well. So we can use the identity cosine of, don't know what that's showing. Okay, cosine of x plus y is cosine x cosine y minus sine x sine y over cosine x sine y. All right, now let's break up this fraction. Cosine x cosine y over cosine x sine y minus sine x sine y cosine x sine y. What can cancel out? Well, these cancel, yeah, and these cancel. So now we're left with cosine y over sine y, which is not tangent, it's cotangent y, and sine x of cosine x is just tangent x. And there we go. We have the right-hand side. Okay, next. Number 13, cosecant x minus tangent x over 2 is cotangent x. Okay, let's start from the left-hand side once again because we know we can use the identity for a tangent of x over 2. Cosecant x minus tangent of x over 2 is equal to, maybe it's also helpful to change cosecant in terms of sine. That's 1 over sine x. And then there's multiple representations for a tangent of x over 2. One of them is 1 minus cosine x over sine x. Okay, the reason I want that representation, even though the other one could work as well probably, is because now that I have a same denominator, I can combine the two fractions. So it's 1 minus parentheses, 1 minus cosine x, don't forget the parentheses, over sine x. So this becomes 1 minus 1 plus cosine x over sine x, which is just cosine x over sine x, which is cotangent x. There we go. Next, 1 plus tangent x times tangent of x over 2 is secant x. Again, let's probably start from the left-hand side, go to the right-hand side. We can kind of simplify the left-hand side. I would not know how to start from secant x going to 1 plus tangent x over 2. Okay, so left-hand side, let's write it one more time. Tangent x over 2. Maybe put some parentheses to make things a little clearer as well as to what's the argument. Equals. So how can we approach this one? Well, 1 plus, maybe let's change tangent x into sine x over cosine x, because we're going to use the identity once again that 1 minus cosine x over sine x is equal to tangent of x over 2. And we see that these signs cancel, so you're left with 1 plus 1 minus cosine x over cosine x. Let's break up that fraction. So 1 plus 1 over cosine x minus cosine x over cosine x. This is just equal to 1. So this is 1 minus 1 is 0. So 1 over cosine x is left, which is secant x. Sine 2x over sine 2x over sine x minus cosine 2x over cosine x is equal to secant x. How shall we solve this one? Probably again starting from the left-hand side. Let's use the double angle identities. Sine 2x is what? This one is 2 sine x cosine x. By the way, this one you should memorize because this will come up in calculus when you do trig integrals, all that. Okay. Same with cosine 2x. That sometimes comes up. Not as often as sine 2x from my experience, but cosine 2x also sometimes comes up. This is what? Cosine squared x minus sine squared x divided by cosine x. Okay? I forgot to write the left-hand side again, so let's be precise with what most teachers, high school teachers, want. Honestly, as a college instructor, they probably don't care about this that much. Original guy equals, okay. Now what can we do? Looks like we can start simplifying and canceling some stuff maybe. So like these sine x is canceled, so I'm left with 2 cosine of x. And over here, I would have cosine squared x over cosine x plus sine squared x over cosine x. Okay, so what am I left with? Cosine x, and this reduces to 1 power. So I have 2 cosine x minus cosine x, so that's just 1 cosine x. Yeah? And then I have, can I do anything here? Maybe let's change the sine squared in terms of cosine squared. That's 1 minus cosine squared x over cosine x. Okay? I see the light. Cosine x, let's break up that fraction. Plus 1 over cosine x minus cosine squared x over cosine x. So these reduce. And then we have a cosine x minus cosine x. So this is what that zeroes out. So we have left over 1 over cosine x, which is secant x. There we go. That's the right-hand side up there. So let me just squeeze it in once more. There's that. There's the proof right there. All right, we're halfway through. Tangent of x plus pi over 4 is equal to 1 plus tangent x over 1 minus tangent x. So let's use the identity for tangent of a plus b equals something. The tangent of x plus pi over 4 is tangent x plus tangent pi over 4, okay, over 1 minus tangent x tangent pi over 4. All right, so what is tangent of pi over 4? It's 1. So on the top, we have tangent x plus 1. On the bottom, we have 1 minus tangent x, which, if your teacher's really picky, just write the exact same thing as the original one more time. Instead of tangent x plus 1, to match what was given on the top right here, let's just flip the two terms, because addition is commutative. Okay, next, this is 17 now. secant x minus 1 over sine x secant x is tangent of x over 2. Which side do we want to start with? Maybe let's start with the left-hand side once again. So secant x minus 1 over sine x secant x. Maybe let's change everything in terms of sine and cosine. So secant is 1 over cosine. Sine we leave alone, and then secant is 1 over cosine once again. Okay. So what if now we multiply by cosine x on the top and the bottom? So then we would get 1 minus cosine x over sine x. Okay? And this is the identity tangent x over 2. This is equivalent. And we're done. This was pretty simple. All right, next. Cosine x plus cosine y quantity squared plus sine x minus sine y quantity squared is 2 plus 2 cosine of x plus y. Which side shall we start with? So either we have to expand everything on the left-hand side, or we start from the right-hand side. Maybe we do some factoring, maybe, perhaps. I feel like I would do the latter. So let's start from the right-hand side this time. Totally valid to start from the left-hand side, but I feel like that's a bit more complicated, at least what I'm predicting. Okay, so let's start from the right. So let's use the cosine of x plus y identity, or cosine of a plus b, or alpha plus beta, whatever your formula sheet probably says, or your textbook. So it's 2 plus 2. Let's open up a bracket. Cosine of x plus y. That is cosine x cosine y minus sine x sine y. Okay? So this is 2 plus 2 cosine x cosine y minus 2 sine x sine y. Okay, so now if we look from here, we have to match this guy. So as I was saying earlier, we probably need to do some factoring. So maybe let's break up this 2 into sine squared plus cosine squared. That's equal to 1, so we need 2 of those. So maybe let's write it as sine, and actually maybe instead of, actually let me just write it first. Okay, so we probably want sine squared x plus cosine squared x. That's equal to 1. And then let's write another one, but with y's instead. Sine squared y plus cosine squared y. And then we have the plus 2 cosine x cosine y minus 2 sine x sine y. We have to be a little creative here. Let me zoom this out a little bit. Okay. So let's start regrouping some terms, because as I said, once again, we probably need to factor into these two guys over there. So sine squared x, actually, okay, let's go in order. What does this guy actually expand to? Let's do it in our head. It's cosine squared x plus 2 cosine x cosine y plus cosine squared y. Do we have that all over here? Cosine squared x plus 2 cosine x cosine y plus cosine squared y. We have it right there. So just for completeness, let me group all those terms together. Plus 2 cosine x cosine y plus cosine squared y. And similarly, if we have expanded that we would get sine squared x minus 2 sine x sine y plus sine squared y. We have those terms right there. Okay? By the way, this is kind of, if you notice, I'm breaking the rule of we can only touch one side. I started touching the other side, but mentally in my head. But we're technically allowed to do that. You just cannot write it as your final answer, but it totally helps to think of what the next steps are. Okay, so I really don't understand why teachers are that picky, especially if they're trying to teach you how to think through these, not so much the organization neatness of mathematical proofs. But I would argue this should be training you to spot patterns and work backwards and stuff like that. But anyway, enough complaining from me. We would have cosine x plus cosine y squared plus sine x plus sine y squared like that, and that's our left-hand side. Okay, next. Cosine of x over 2 minus sine of x over 2, all that squared equals 1 minus sine x. So in this case, I wouldn't know how to start from 1 minus sine x to get to that left-hand side. So let's start from the left-hand side this time. Cosine x over 2 minus sine x over 2, all that quantity squared equals, let's expand this out. So it'll be cosine squared x over 2 minus 2 sine x over 2 cosine x over 2 plus sine squared x over 2. Well, cosine squared plus sine squared of the same argument is equal to 1. So it's 1 minus 2 sine of x over 2 cosine x over 2. So somehow this is equal to sine x. What can we do? Does this look any bit familiar? Look at your identity sheet if you have one. This is a double angle formula. 1 minus sine of 2 times x over 2. Because sine of 2x, or sine of 2u, let's say, is, let me write on the side. Sine of 2u is 2 sine of u cosine of u. So sine of, replace u with 2u with just u, so we half that. So it'll be 2 sine of u over 2 cosine of u over 2. Okay? You have to be a little bit flexible with these identities. It doesn't have to look exactly like it, but you can replace it like a function as well. Okay, so this is just 1 minus sine of x, and we're done. Okay, last one for this video. Cosine of 3x minus cosine 7x over sine 3x plus sine 7x is tangent 2x. I wouldn't know how to start from the right-hand side, sorry, to get to the left-hand side. So let's use the, let's start from the left-hand side. Cosine 3x minus cosine 7x over sine 3x plus sine 7x. This does sum to product formulas. So if we use it, cosine of A minus cosine of B is something on your identity sheet, hopefully. Otherwise, you have to memorize it. It is, so minus 2 sine of, it'll be the sum, so 3x plus 7x would be 10x over 2. Cosine, you take the difference, 3x minus 7x, that's minus 4x over 2. Over sine A plus sine B, that's identity as well, is 2 sine of the sum and cosine of the difference again. Okay, so clearly these twos cancel, these cancel. You're left with those over there. Actually, I did not write the identity right. It's 2 sines on the top and sine cosine. Okay, there we go. So this is just minus tangent of minus 4x over 2. Let me write it a little bit better. Okay, because sine over cosine of the same stuff is tangent, yeah? Now, this obviously simplifies to tangent of minus 2x. Now, how does negative tangent negative 2x equals tangent 2x? Well, tangent is an odd function. So remember what odd function is? F of negative x is equal to negative f of x. Okay, so if I really want to show my work, this is negative 1 times another negative 1 times tangent of 2x. So this is just tangent of 2x, positive. Okay. All right, that's it for this video. Hopefully this is good practice. You can see, hopefully, the strategies general strategies I use. Typically, I start from something more complicated and I work with the simpler thing. Typically, not always the case. And then you should honestly just spot what things you can use for identities, like this double angle right here. This one, the cosine x plus y, you can expand out to the cosine x cosine y minus sine x sine y. Okay, tangent x over 2, you can use the half angle stuff. Same thing there. Double angle stuff, sine 2x cosine 2x. That's one on the identity sheet, or one that you should just memorize because you need it for calculus. Tangent x plus 4, that's the sum identity. Things like that. Okay, that's honestly the best way to go about it. Search for things that you can use identities for from your identity sheet, or you just have to have those identities memorized. And then, quote unquote, simplify or manipulate from there.